In May 1902, in the National Archaeological Museum in Athens, a man named Spyridon Stais walked past the prize of the Antikythera Hall, a bronze youth, restored, gleaming, drawing every eye in the room, and stopped instead at something no one had bothered to examine: dull green crusts, broken bronze, scattered near the statue like scraps from a ruined fitting. He picked one up, turned it. Teeth, not decoration, gear teeth. Then letters, faint under oxide and salt, pressed into metal that had spent 2,000 years on the floor of the Aegean Sea. Within hours, archaeologists, epigraphers, and numismatists were crowding around a few corroded plates from the sea, arguing over what they were looking at. An astrolabe, some said, a navigational instrument, something to do with astronomy. None of them had the language for it yet. They had found the most sophisticated object the ancient world ever produced, a machine that could model the movements of the sun, the moon, and every planet visible to the naked eye, all from a single rotation. They found it, and they still haven't finished explaining it. To understand what was lying in that museum box, you have to go back further than the wreck, further than the divers, further than the sea. You have to go back to a world where this machine made sense. In the 2nd century BCE, the Greek world was fracturing. Rome was expanding. The wars that followed, the Mithridatic Wars, the grinding absorption of the Eastern Mediterranean into Roman power, left Greek cities exposed in a way they had not been for generations. Gymnasia stripped, statues taken, libraries moved, centuries of civic life reduced to inventory for Roman taste. Rhodes survived longer than most. And on Rhodes, in the years before that slow collapse, there existed a tradition of astronomical craftsmanship that the rest of the ancient world regarded as extraordinary. Scholars, engineers, mathematicians who could model the sky in bronze. We know this tradition existed not only because of the mechanism, we know it because Cicero told us. In De Republica, written around 54 BCE, Cicero describes seeing a device attributed to Archimedes, a sphere of bronze, and when you turned it, when you applied a single rotation, the sun moved, the moon moved, all 5 planets moved, each at its own speed, each on its own path. By a single device for turning the globe, those various and divergent movements with their different rates of speed. Una conversio, one turning motion. The mechanism belongs to that tradition. It is not Cicero's sphere. Archimedes died in 212 BCE, and the mechanism was built roughly a century later. But the mathematics descend from the same Hellenistic world, the same island. The shadow of Archimedes falls across this machine not as its maker, but as its ancestor. The mechanism itself is small, roughly the size of a shoebox. 30 bronze gears survive. The full machine likely had 69. A front face showing the cosmos in motion, a back face tracking time, the 19-year Metonic cycle, the Saros eclipse spiral, a 4-year dial marking the Panhellenic Games. It calculated the moon's irregular orbit. It predicted solar and lunar eclipses, not just when, but their magnitude, their direction, their color. It was not made for wonder. It was made for use. Someone built this machine in a world that was already beginning to disappear, and someone put it on a ship. The ship went down somewhere between 60 and 50 BCE in the waters off the small island of Antikythera, a scrap of rock between Crete and the Greek mainland, on the route that cargo vessels took from the eastern Mediterranean toward Italy. It was found in the spring of 1900, not by archaeologists, by sponge divers. A fleet of Semiote divers, working the eastern Mediterranean, stopped near Antikythera during a storm. One of them, weighted down, descending into cold water, hit the seabed and found a field of bronze and marble, arms, legs, faces, an entire world of objects lying in the silt. He surfaced, holding a bronze forearm. What followed was the first major underwater archaeological expedition in history, backed by the Greek Royal Navy, staffed by the same sponge divers who made the discovery. They dove repeatedly into waters that were, by the standards of 1900, genuinely dangerous. One diver died, 2 others were left paralyzed. The haul they brought up was extraordinary. 36 marble statues, bronze figures, pottery, amphorae, jewelry, glass, and, in what was catalogued as a mass of corroded bronze, the mechanism itself, sealed inside an encrusted slab, its gears invisible, its function unknown. The cargo raises questions the salvage never answered. The amphorae point toward Rhodes and Kos and Ephesos. The coins, a hoard of cystophoric issues, point to the province of Asia, the latest dated between 76 and 67 BCE. The statues are Parian marble, the kind quarried by craftsmen with access to Cycladic stone. This was not a merchant's ordinary inventory. The scale was wrong. The character was wrong. 36 statues, bronze figures of philosophical and athletic subjects, objects that looked less like household decoration and more like the contents of a public building, a gymnasium, a civic space. The gymnasia of the Greek East had been emptied before. After the Mithridatic Wars, Roman commanders moved through these cities with authority and appetite. What couldn't be taxed could be taken. What couldn't be taken could be bought for nothing from men with no choice. The newest study of this cargo, published in 2025 in the Annual of the British School at Athens, uses a specific word for how it was assembled: plunder. The mechanism was on that ship, built in a world that was vanishing, loaded onto a vessel carrying what was probably someone else's property, and the sea took all of it. Price was the first to take it seriously. Working in the 1950s and 1970s with physicist Charalampos Karakalos, using X-radiography on the surviving fragments, he proposed what no one before him had committed to in print: a mechanical calendar calculator, an ancient Greek analog computer. His reconstruction was incomplete. His gearing scheme was partly wrong, but he established the field. Between 2005 and 2008, the Antikythera Mechanism Research Project applied microfocus X-ray CT scanning to all surviving fragments. They doubled the number of readable inscriptions. They confirmed the gear trains. They identified the metonic spiral, a 5-turn dial covering the 19-year cycle that reconciles lunar months with solar years. The Saros eclipse dial, a 4-turn spiral of 223 lunar months. Glyphs encoding not just whether an eclipse would occur, but its type, its magnitude, its color. The angular diameter of the moon, the Olympiad dial, a 4-year cycle tracking the Panhellenic Games. The back of the mechanism is the most secure part of the reconstruction. The front is harder. The 2021 reconstruction proposes 69 gears total. Rings representing the Earth at center, then Mercury, Venus, the Sun, Mars, Jupiter, Saturn, the Zodiac, the Egyptian calendar. A moon phase sphere. A dragon hand tracking the lunar nodes. That model is a reconstruction, not a readout of surviving hardware. Because the front gearing, The system that calculated the true sun and the superior planets does not survive. No surviving direct evidence. The 2021 paper states this plainly. The space constraints and the inscriptions limit the options. The gears themselves are gone. We are reading a machine with missing pages. The history of science has an answer for the mechanism. It belongs to a Hellenistic tradition of geared astronomical modeling. Greek craftsmen of the 2nd century BCE had the knowledge. Toothed gearing, precision instruments, water clocks, armillary spheres. The mechanism is their highest surviving expression. Rhodes was likely its origin. The tradition was real. The machine was possible. The answer holds, and the silence that follows it does not. A Byzantine sundial calendar dated 400 to 600 CE, the second oldest known geared device of its kind. It tracked time across 16 locations, displayed the moon's phase. Scholars note it with care, because after Antikythera, it is next, and it is far simpler. A geared astrolabe made in Isfahan in 1221 CE. The History of Science Museum at Oxford calls it the oldest complete geared machine in the world. It explicitly places the object in a tradition reaching back, largely lost, to Antikythera. Then nothing comparable until the planetary clocks of the 14th century. Nature's 2006 paper states it directly. The mechanism was technically more complex than any known device for at least a millennium afterward. The tradition didn't continue. It attenuated, changed form, mostly disappeared from the record. Not because the knowledge was impossible, because the world that needed it and could sustain it stopped existing. The machine had no equal for 14 centuries. The mechanism sits today in the National Archaeological Museum in Athens. Fragment A, the largest piece, is in a climate-controlled case. The gear teeth are visible, the inscriptions partially legible, the cosmos it once displayed partially reconstructed. It has been there since 1902. The world that built it is gone. The ship that carried it is gone. The Greek cities whose gymnasia were stripped to fill that cargo, gone. What's left is the object, corroded, incomplete. The newest study of the ship's cargo concludes it was probably plunder, civic objects taken from Greek public spaces and headed for display in Rome. There is no invoice, no owner's mark. No surviving inscription names the city it was taken from, or the man who ordered it taken. The mechanism was part of that cargo. It made the same journey. It went into the same water. We rebuilt the machine. We decoded the eclipse predictions. We reconstructed the rings of the cosmos it displayed. The sun, the moon, Saturn at the outer edge, the zodiac beyond that. The front gearing is still missing. 69 gears in the full reconstruction, 30 survive. The machine outlasted everything. One turning motion. The world that built it is gone. The machine is still turning.